Hello viewers, I am Bikshamaiah, Assistant Professor of Physics from Government Degree College for Women, Nalgonda. Today I am going to deliver a lecture on thermodynamics basics. So the basics are important, especially we are going to study the terminology. So if we understand the terminology only, we can understand the rest of the part. So I am going to focus on the terminology in thermodynamics. So we'll see now. So this one. So thermodynamics. It is the science of energy transfer and its effect on the physical properties of substances. Okay, it is the science of energy transfer and the effect of energy transfer on physical properties of substances. Okay, and in other words, we can say it is the experimental science. That means whatever the laws and principles are established, they are based on the observations of experiments. Therefore, we can say it is the experimental science. The study of behavior of matter can be studied in 2 points of views. Okay, one is macroscopic point of view. You can study the behavior of the matter in microscopic point of view and macroscopic point of view. So macroscopic point of view is also called as classical thermodynamics, and microscopic point of view is also called as statistical thermodynamics. We see why the name is given for the statistical also. So in macroscopic approach or in macroscopic point of view, a certain quantity of matter is considered without taking the events occurring at molecular level into account. That means we consider a matter and we do not take into account the occurring of events at molecular level. So it is the macroscopic point of view. We consider some matter and we study about the properties only, properties of the substance only, but we do not see inside what is happening at molecular level or atomic level. So in microscopic approach, we see at atomic level or molecular level. Therefore, in microscopic approach, matter contains thousands of molecules or millions of molecules. So for each molecule, in order to know the energy of a particular molecule, we have to know the momentum coordinates of that molecule. Okay. So the momentum coordinates of that molecule and positions. So in that way, we need 6 coordinates. So to identify the position of a molecule or atom, we need XYZ coordinates, and to know the velocity or momentum or its energy, we have to know the 3 velocity components or coordinates of each molecule. So in that way, so we have to know. So corresponding each molecule, there exist 6 coordinates. So if you have any number of molecules, so we have to multiply with those number of molecules into 6. So if we have here, we have 10 power 20 molecules, let us say in a cube. So 10 power 20 molecules. Sorry. So the corresponding coordinates, it becomes 6 into 10 power 8, 6 into 10 power, sorry, 20, and we have to deal with those many number of equations. Here we are seeing 8, but it should be 20. Okay, right. So we have to deal with those many equations. So it is very difficult for a human being and also for the computer also. It takes much time to solve such equations and to come out with some expression. Okay, useful result. So that type of study is a microscopic point of view. So it is difficult. We can minimize this. We can make simple the study of microscopic point of view in two ways: by reducing the equations, by reducing to some extent the number of equations, or by studying the average properties of the substances. So that's what we do in macroscopic point of view. That comes under macroscopic point of view. The macroscopic implies we are concerned with the gross or average effects of many molecules. Okay, so the macroscopic properties are the properties or the average properties of many molecules. That means whatever the effect occurs, so that is because of not a few molecules, it is because of many molecules and their average. Okay, the average effect of many molecules gives us the macroscopic properties. These effects can be perceived by our senses and measured by instruments. The macroscopic properties can be measured and we can sense with our human organs. So what we really pursue and measure is the time averaged influence of many molecules. So it is not the, if we measure particular point, particular property, it is not the property of particular instant time. Okay, it is the time average of the that property over some period. So we can take one example for this. If we measure our body temperature, so we keep the thermometer in our mouth for some time, at least for 1 minute or for 2 minutes. That means in that time, most of the molecules touch the surface of the thermometer and they transfer energy to thermometer. So in that way, so it is a property of many molecules and it is the time averaged property. Time averaged property. So that's what we observe, we can sense or we can measure. Those quantities are time averaged influence of many molecules. Okay. The results of macroscopic thermodynamics can be derived from the microscopic thermodynamics. So the microscopic thermodynamics is the ultimate. That means these properties come from that one only. We can derive macroscopic thermodynamic properties from microscopic thermodynamics or thermodynamic properties. Okay. Now, thermodynamic system. It is it is a concentrated quantity of matter or region in space in the analysis of study of a problem. So simply we can say it is a concentrated quantity of matter or matter in space, or it is a concentrated region in space. Okay, so relating to a particular problem, relating to a particular problem. Okay, that is the thermodynamic system. So if we are studying the properties of a gas in a cylinder, let us say, if we are studying the properties of a gas in a cylinder, so the matter plus device comes under the system. That means we may get some doubt. Is only the gas system, is the only gas is a system, or gas plus cylinder together is a system? So gas plus cylinder together is a system. So here we are generalizing. So matter and device, the two, the matter plus device is called system. Okay, or it may be bowel, we can say. So in case of cylinder, we are calling it as a bowel now. Surroundings or environment. These two words are same, equivalent. Surroundings or environment. That means we have known now system. What is a system? Everything that is external to the system is called surrounding or environment. Okay. So if our gas with gas inside a cylinder, that means the cylinder with gas is a system, our system. So everything else outside the cylinder is the surrounding or environment. Now the system is separated from the surroundings by system boundary. Okay, the system is separated from the surroundings by system boundary. So that means the system and surroundings are separated by a boundary. That boundary is called simply a boundary or system boundary. Okay. So the boundary may be, the system boundary may be fixed or movable. Okay, it depends on the what situation we take or the what problem which is related to us. Okay, a system and its surroundings can be together comprise universe. So the combination of these two is called as universe. Okay, universe. There are three types of systems. So isolated system, closed system, and open system. So isolated system, closed system, open system. So isolated system, if there is no transfer of mass and hence obviously the energy across the system boundary. So that means if no matter passes through the system boundary, at the same time no transfer of energy also, that type of system is called isolated system. Okay, closed system. So here there is no transfer of mass, but there is transfer of energy across the system boundary. So such systems are called closed systems. Okay, open system. So there is a transfer of mass and energy. Whenever there is transfer of mass, obviously mass, we can say matter, a matter consists from energy. Okay, therefore there is a transfer of mass and a transfer of energy across the system boundary. So such systems are called open systems. Okay, so whenever there is no mass transfer, there are two possibilities. There may be energy transfer, and there there may not be there may not be energy transfer through the boundary. Okay, if there is no energy transfer across the boundary, in addition to the no transfer of mass, isolated, there is transfer of no transfer of mass, but there is transfer of energy, that is in case of closed systems. So if we take one example in a comparative way, so tea in a thermal flask. So we use generally in our homes thermoflask. So it contains two walls. So thermally isolated walls. So to prevent heat convection and heat conduction, so especially designed device. Okay, tea in a thermoplast is an example for isolated system we can take. So because if we power the tea in that thermoplast, it it stays warm or hotter for long time. Okay. So closed, the example for this, the similarity in a copper bottle with closed cap. Okay. The closed container with a metal, we can say any metal. So since that is closed, there is no chance for transfer of mass, but the body material is a thermally conducting. If it is a thermally conducting, and there is transfer of heat energy through conduction process, Therefore, tea in a copper bottle or any metal bottle with closed cap is the example for closed system. And the example for open system, tea in any cup. Okay, it is an example for open system. That means in a teacup, so that is not closed. So it contains some volume, but open. It is open. So since it is open, matter can escape from the open, and that is the chance. So there is transfer of mass. Whenever it is open, there is a chance for transfer of mass, and at the same time, so it is open, and there is chance for transfer of energy also. In this case, so the tea become cool through the process of convection, heat convection, and heat conduction also. So the heat will be conducted to the gas which is in touch with the surface of the tea. Okay, here two process. Here only one process. Here conduction only. Here conduction and convection possible. Here no convection possible in isolated case. So here I am showing with diagrams. So it is example for isolated. That means pictorial representation. So we can treat this. It is a double wall, and it is isolated wall. We can say if it is a bigger wall, uh, it is isolated wall. That means isolated means thermally bad conductor, thermally not conducting wall, and impermeable, and it does not permit the matter to escape through it, through this boundary. So it is the boundary. So whatever the matter inside, that one is matter plus this device is called system, and outside this walled area, boundary, outside the boundary, system boundary is called surrounding. So system, this one white area and this one together system, and outside area surrounding. So it is isolated. The wall is thermally insulated and impermeable wall. So here it is a picture for closed system. So here we are seeing wall, a thick wall. So it is not a double walled. So Of course, here it may be double wall or single wall, but it is thermal insulating. Here, a wall which is thermally conducting wall, but it does not allow the matter to escape through it. Therefore, it is a closed system. Here we are seeing similar material exist here, but there are some holes. So it need not be many holes. Even if there is only one hole, the matter can escape through it. So therefore, if such walls exist, and this one, it is the chance for mass transfer and energy transfer. So it is an example for open system. Okay, that's one. Now the characteristics, we are seeing the definition of properties. The characteristics of a system by which its physical condition may be described are called the properties. The properties are nothing but the characteristics of a system. With the help of characteristics, we can describe the physical condition of the system. Okay, such characteristics are called properties. So the examples: pressure, volume, temperature, and entropy, enthalpy, energy, density. All these are the properties. Okay, when all the properties of a system have particular values, the system is said to be in definite state. Okay, if we know the values by certain amount, that means the particular value or definite value, so we can say that the system is in definite state. So that one. Any operation in which one or more properties of a system changes, so that operation is called change of state. That means if at all there is a change in either one property of the system or more than one property of the system during one operation, so that one is called change of state. Okay. Next one, the succession of states passed through during a change of state. So that one is called the path of the change of the state. That means a continuous states. That means a discrete states we can say. So the system is changed from one state to another state through intermediate states. So through different intermediate states. So such the locus of points we can say, that means we represent the state of the system in PV diagram with a point. Therefore I am saying the different points, a sequence of points is called the path of the change of the state. Simply we can say the path of the change. Okay, that's one. That means the continuous intermediate states called the path. So when the path is completely specified, the change of state is called a process. Okay, so in above path, every state, so I have told here the succession of states, every state is known or specified. So that change of state is called a process. Or simply here we are seeing the change of state is an operation. So that is one operation or action. So therefore that is during that operation, if the state of the system is completely specified, that one is called a process. Now we see a process in which final and initial states are identical. So that process is called a cyclic process. or the thermodynamic cycle. Thermodynamic should be cycle. So that means we know the process. It is the change of state. A specified change of state is a process. So in particular process or in a process, final and initial states are same or identical. That process, or we can say the state, the state of the system, the final state of the system reached the initial state of the system. So initially it is existing at a particular state, and we are doing some operation. The state is being changed over the time. After some time, if it comes to the initial state, that means the state, the properties of initial, the properties of final state of the system is same with the properties of the system at initial. So that process is called cyclic process or thermodynamic cycle. So two types of properties. There are two types of properties: intensive properties and extensive properties. If we see the intensive properties, so the properties which are independent of amount of substance are independent of mass of the substance. Okay, so the properties which are independent of amount of substance are which are independent of mass of the substance. So therefore, we can say the properties which depend on mass, those are intensive properties. So we are saying amount of substance. That means if it is okay, which independent of, actually I said it is not the mass. So the mass comes in this extensive parameter or extensive properties, since it is dependent of amount of the substance or dependent of mass of the substance. Therefore it is dependent on mass, so the terms mass is the extensive, and the properties which depend on mass are also extensive. Similarly, here we are saying amount. Therefore, amount of the substance increases. If amount of substance increases, the volume of the substance or material increases. So therefore, volume is extensive parameter, mass is extensive parameter, and the mass increases, energy also increases, and entropy, enthalpy, Gibbs free energy, all these are energies. So therefore, these are also extensive parameters. So in the examples for intensive, the pressure inside. One more thing, the intensive parameters or intensive properties are the same over the entire substance or over the entire system. Even your system may be total, or you can separate by small amount. So that particular property is same in both the things. Over the entire system, that property is same, and if you separate some small portion from the system, in that small part also, the if that property is same with the property of whole system, such properties are called intensive properties. Pressure, so in case of homogeneous systems, so pressure obviously will be same over the entire system, and temperature also. Similarly, the chemical potential also. If the system is divided into several parts, okay, if we are dividing the system into subsystems or parts, the value of total extensive property of a system must be equal to the sum of the values of the parts or subsystems. So that means if we are having, or we have the extensive property of whole system at first. So after that, if we divide the system into parts, so In second case, if we calculate the extensive property of different parts, the addition of all these parts should be equal to the total extensive property of the substance or a system. Okay, we can say from this, we can say extensive properties are additive quantities. Additive quantities, we can add them. So that is not the case in case of intensive properties. Okay, one more point, extensive properties per unit mass are called intensive properties. So if we take particular extensive property and for you that property per unit volume, that converts to intensive property. That means that will be independent of mass. Since we are calculating per unit mass, therefore that will free from mass. So then it becomes intensive property. So there is some example. Specific volume, intensive property, specific energy, specific volume is intensive property, and specific energy, intensive property, and density also intensive property, viscosity, intensive properties. So density is a mass by volume. Mass is extensive and volume is extensive, and the ratio we are getting intensive property. So another one, phase. A phase is a quantity of matter which is homogeneous throughout the system in chemical composition and physical structure. So the quantity of matter which is homogeneous, if the matter is homogeneous throughout the system in chemical composition and physical structure, so that is a phase. Okay, so we can say that one as phase. Generally the matter exists in three stable phases. So there exist other phases also. So those three stable phases are solid phase, liquid phase, and vapor phase or gaseous phase. So there is one more phase, plasma, so that occurs at very higher energies, and even we are now saying the fifth state of matter as Bose-Einstein condensate state. But so those states, so and there are some other states also, superconducting state, so just like that. So those states exist, those phases exist under extreme conditions only. They are not stable at room temperatures or as long time, for long time. Okay, they are not stable. So the stable phases, solid, liquid, gaseous, and one more thing we can say, plasma. So that occurs in celestial bodies. So that is a phase. According phase, so homogeneous and heterogeneous system. So if a system consisting single phase, if a system is consisting a single phase of the matter, that system is called homogeneous system. So if a system is consisting more than one phase, so such system is called heterogeneous system. Okay, homogeneous and heterogeneous systems. So in this lecture we have learned, so what is a thermodynamics? So it is the science of energy transfer and the effect of energy transfer on the physical properties of substance. So after that, macroscopic point of view, microscopic point of view. So in macroscopic point of view, we do not take into account the activities of or the events occurred at molecular level or atomic level. So we study the properties of the substances or matter, and we can sense the macroscopic properties, or we can measure by an instrument. So those properties are measurable. So in case of microscopic, that the we study the matter at microscopic level. So in a particular substance, even in 1 mole, we have 10 power 23 atoms. So very big number. Corresponding to that, corresponding to each atom, there exist 6 coordinates, 3 position coordinates, 3 velocity coordinates. We have to study so in terms of positions and velocities. So it is quite difficult. Okay, that one we have seen. And so system, it is a concentrated quantity of matter or region in space. So simply we can say concentrated quantity or a area of interest in space also. So that is system, and everything the outside the system is called surrounding. Okay, that one. Now a boundary, there exists a boundary which separates system and surroundings. So system and surroundings together are called as universe. Okay, so there are three types of systems: isolated system, closed system, and open system. In isolated system, there is no transfer of mass and there is no transfer of energy. So in closed system, there is no transfer of mass, but there is transfer of energy through system boundary. So that means from system to surrounding. So open system. In case of open system, there is a transfer of mass as well as transfer of energy from system to surrounding or through system boundary. So we have discussed that, and so uh, it is the process from A to B is the process. So here we are seeing A to is a process. Okay, change of state. If we is such, okay, change of state, and it is specified change of state is called the process A to B. Now, in a cyclic process, we have studied or discussed cyclic process. It is, that means in one process it is going from one state to another state, state 1 to state 2 at first. Later, so it is coming to the initial state. Okay, we can keep the directions also. It is important to keep direction also, arrow we have to put. So it comes to a different state in one path, and it is going to initial state in another path. Anyway, so at one position one, so final, it is the final state, and the final state is coinciding with the initial state. That means they are attaining the same physical properties. So at point one, so initial and final position same. That means the system is having same pressure and the same volume, same pressure and same volume. So it is called a cyclic process. It is a process. So the intermediate states, A is one state and B is another state. So the intermediate states are also identified here. So, and this series or succession of states in between the initial and final states is called a path. So it is one path. Whatever we are seeing the line or curve, that is a path, path of the system changed. So here also in cyclic process we are observing two paths. Okay, just like that. Here we are seeing path and process and cyclic process in this diagram. So intensive properties and extensive properties. So the properties which dependent on mass and amount of substance are called extensive, and the properties which are independent of amount of substance or mass of substance are called intensive properties. The examples for intensive properties: pressure, temperature, chemical potential, and the examples for extensive: volume, energy, entropy, enthalpy, Gibbs free energy, Gibbs free energy. So these are. And the ratio of extensive properties also gives us intensive properties, or extensive properties per unit volume gives us intensive properties. So such examples are specific volume, specific energy, and density. Okay. So here I am stopping. Thank you very much for watching.